Download this code from codegive.com, link in the description below. perfview, the ultimate .NET performance tool, a comprehensive tutorial. perfview is a powerful, free performance analysis tool for .NET applications on Windows. Developed by Microsoft, it allows you to collect and analyze performance data, identify bottlenecks, and understand the runtime behavior of your code. It's particularly valuable for understanding the intricacies of the .NET garbage collector, GC, JIT compiler, and threading. This tutorial provides a detailed guide to using perfview, covering its key features, common use cases, and how to interpret the results to optimize your .NET applications. Installation and basics *. 1. Download *Download perfview directly from the Microsoft repository, https://github.com/microsoft/perfview/releases, https://github.com/microsoft/perfview/releases. 2. Installation * perfview is a self-extracting executable, perfview.exe. Simply run it and choose a directory to extract the files. There is no traditional installer. 3. Running as administrator * perfview requires administrative privileges to collect system-wide performance data. Right-click on perfview.exe and select Run as administrator. 4. Basic usage * Collection * perfview collects data using event tracing for Windows, ETW. ETW is a system-level tracing mechanism in Windows that allows you to capture various events emitted by the OS and applications. Analysis * perfview analyzes the collected ETW data and presents it in a user-friendly way, including charts, tables, and call stacks. 2. Collection methods * perfview offers several methods to collect performance data. 1. Collect *. This is the primary method for collecting performance data from a running process or the entire system. To collect data from a running process *. Start your .NET application. In perfview, go to collect-collect. In the process name field, select the process name of your application, example myapplication.exe. Configure the collection options, see below. Click Start Collection. Reproduce the performance issue you want to analyze in your application. Click Stop Collection. To collect system-wide data *. In perfview, go to collect-collect. Leave the process name field blank. Configure the collection options, see below. Click Start Collection. Reproduce the performance issue you want to analyze. Click Stop Collection. Collection options *. Data file * specifies the name of the .etl, event trace log, file where the collected data will be stored. Circular file * if checked, perfview will use a circular buffer, overwriting older data if the buffer fills up. Useful for long-running processes. Merge * if checked, perfview will merge the new ETL file with any existing ETL file of the same name. Max size, MB specifies the maximum size of the ETL file. Zip * compresses the ETL file after collection. No NGEN symbols * excludes NGEN, native image generator, symbols from the ETL file, reducing its size. NGEN is used to precompile .NET assemblies to native code. If your code uses many third-party libraries, you might want to enable this option. CLR events * specifies the .NET CLR, Common Language Runtime, events to collect. The default options are generally sufficient for most scenarios. You can customize this to focus on specific aspects like GC, JIT, or exceptions. .NET symbols * specifies whether to collect .NET symbols, PDB files. Symbols are essential for resolving managed code addresses to method names. Make sure your PDB files are available, either locally or from a symbol server. Include native images *. Check this box if you wish to see native images stack traces. Advanced options * allows fine-grained control over ETL session parameters, provider configurations, and kernel events. To run *, this method starts a new process and collects data while it runs. In perfview, go to collect-run. In the executable field, specify the path to your .NET executable. Configure the collection options, similar to the collect method. Click Run. 3. Attach *. This method attaches to an existing process and starts collecting data. Similar to collect, but assumes the process is already running. 4. Collect CPU samples *. A simpler way to collect CPU sampling data. Useful for getting a quick overview of CPU usage without the overhead of full ETW tracing. Less data is collected compared to collect, but it's faster and may be sufficient for initial investigations. 3. Data analysis ***. After collecting data, perfview opens the ETL file and provides various views to analyze the information. The most important views are 1. CPU usage stacks. This view shows the call stacks that are consuming the most CPU time. It's the starting point for identifying performance bottlenecks in your code. Interpreting the CPU usage stacks view ***. Inclusive samples ***. The total number of CPU samples that include the function, i.e., the function itself or any function it calls. Exclusive samples ***. The number of CPU samples where the function itself was directly executing, not a child function. Module ***. The name of the module, DLL or exe, where the function is defined. Function ***. The name of the function. Symbol resolution issues ***. Perfview requires symbols, PDB files, to resolve addresses to function names. If you see addresses instead of function names, you need to configure symbol paths. Example ***. If you see that a function named myExpensive has a high inclusive samples percentage, it indicates that this function, or functions it calls, is consuming a significant amount of CPU time. You should then investigate the code within myExpensive and its calls to identify the specific bottleneck. 2. Garbage collection, GC, stats ***. This view provides detailed information about the .NET garbage collector. Key metrics ***. Gen 0/Gen 1/Gen 2 collections ***. The number of collections for each generation, Gen 0 is the youngest, Gen 2 is the oldest. A high number of Gen 2 collections can indicate memory pressure and performance problems. Pause duration ***. The total time spent in GC pauses. High pause durations can cause noticeable delays in your application. Allocated bytes/sec ***. The rate at which memory is being allocated. High allocation rates can contribute to GC pressure. Gen 0 size, Gen 1 size, Gen 2 size ***. The size of each generation after a GC. Percent time in GC ***. The percentage of time the application spent in GC. A high percentage means the GC is working hard, which impacts performance. Interpreting GC stats ***. High Gen 2 collections * indicates that objects are being promoted to older generations, and the GC is spending more time cleaning up memory. This can be caused by long-lived objects or excessive object creation. Long pause durations * can cause noticeable stuttering in the application. Can be mitigated by reducing allocations, using smaller objects, or tuning the GC settings. High allocation rate * indicates that the application is creating many objects. Consider object pooling or reducing the number of allocations. 3. Memory allocation, Stacks. This view shows where memory is being allocated in your code. It helps you identify areas that are contributing to high allocation rates and GC pressure. Interpreting the memory allocation, stacks, view asterisk. Similar to CPU usage, stacks, this view shows the call stacks responsible for memory allocations. Focus on functions with high inclusive bytes allocated values. For JIT stats asterisk. This view provides information about the .NET JIT, just-in-time, compiler, which compiles intermediate language, IL, code to native code at runtime. Key metrics asterisk. Compile time asterisk. The total time spent in JIT compilation. Methods JIT asterisk. The number of methods that were JIT compiled. Failures asterisk. The number of JIT compilation failures. Cache hits asterisk. The number of times the JIT compiler was able to reuse previously compiled code. Interpreting JIT stats asterisk. High compile time asterisk can indicate that the JIT compiler is a bottleneck, especially during application startup. Consider using NGEN to precompile assemblies. Low cache hits asterisk indicates that the JIT compiler is repeatedly compiling the same code. This can be caused by dynamic code generation or changes to the code at runtime. 5 threads asterisk. This view shows the active threads in the process and their CPU usage. Interpreting the threads view asterisk. Identify threads that are consuming a high percentage of CPU time. Analyze the call stacks of these threads to understand what they are doing. Look for signs of thread contention, example threads blocked waiting for locks. 6 events view asterisk. This allows you to view all the raw ETW events collected. It's a more advanced view and can be used to investigate specific issues that are not easily visible in the other views. 4. Symbol configuration asterisk asterisk. Perfview needs symbols, PDB files, to resolve addresses to function names in the call stacks. If you see addresses instead of function names, you need to configure symbol paths. 1. Configure symbol paths asterisk. In perfview, go to Options-Symbol Paths. Add the paths to your PDB files. You can also add symbol server URLs, example https://msdl.microsoft.com/download/symbols, to download symbols from Microsoft's symbol server. Use the semicolon, winky face, to separate multiple paths. Press OK. To resolve symbols asterisk. After configuring symbol paths, you may need to explicitly tell perfview to resolve the symbols in the loaded ETL file. Click File-Load Symbol Files. This can take some time depending on the size of the ETL file. Common use cases with code examples asterisk. 1. Identifying CPU bottlenecks asterisk. Scenario asterisk. Your application is slow and CPU bound. Code example, example slow method. Steps asterisk. 1. Run the code. 2. Collect data from the running process using perfview, collect-collect. 3. Open the ETL file in perfview. 4. Open the CPU usage, stacks, view. 5. Look for functions with high inclusive samples percentages. 6. In this case, you'd likely see CPU-intensive task.run or math.sqrt as a major contributor to CPU usage. 7. Optimize the code, e.g. use a lookup table or use a faster implementation of math.sqrt if possible, consider using parallelization. 2. Analyzing garbage collection performance asterisk. Scenario asterisk. Your application experiences frequent or long GC pauses. Code example, example excessive allocations. Steps asterisk. 1. Run the code. 2. Collect data from the running process using perfview. Make sure to enable the CLR events option with relevant GC events. 3. Open the ETL file in perfview. 4. Open the GC stats view. 5. Analyze the GC metrics, such as the number of Gen 2 collections, pause duration, and allocation rate. 6. Also, look at the memory allocation, stacks, view to find the code allocating the most memory. In this case, you would see allocation generator.generate allocations and system.stringter as significant contributors to allocations. 7. Optimize the code, use a string builder for string manipulation, reuse existing string objects, or use object pooling. Reduce the number of allocations. 3. Investigating JIT compilation issues *. Scenario * Your application has a slow startup time or performance issues related to JIT compilation. Code example, unoptimized code. Steps * 1. Run the code. 2. Collect data from the running process using perfview. Enable the CLR events option and include JIT events. 3. Open the ETL file in perfview. 4. Open the JIT stats view. 5. Analyze the JIT compilation time and the number of methods JIT compiled. 6. Optimize, run NGEN on your application. Examine your code and use simpler constructs which the JIT compiler can more easily optimize. Consider caching or memoization of frequently used calculations. 4. Diagnosing threading issues *. Scenario * Your application is slow due to thread contention or blocking. Code example thread contention. Steps * 1. Run the code. 2. Collect data from the running process using perfview. 3. Open the ETL file in perfview. 4. Open the threads view. Look for threads that are blocked for long periods of time. 5. Open the CPU stacks view and filter by those threads. You'll likely see a high inclusive samples percentage for methods related to locking, example system.threading.monitor.enter. 6. Optimize, reduce lock contention by using finer-grained locking, lock-free data structures, or using alternative synchronization mechanisms, example spin lock, reader-writer lock slim. 6. Advanced features ***. 1. Command line usage ** perfview can be used from the command line for automated data collection. This is useful for continuous integration environments. 2. Custom providers ** perfview allows you to collect events from custom ETW providers that you define in your application. 3. Filtering ** perfview allows you to filter the data in the various views to focus on specific areas of interest. 4. Symbol server configuration ** perfview can be configured to download symbols from symbol servers, example Microsoft Symbol Server. This is essential for resolving addresses to function names. 5. Memory analysis ** perfview has advanced features for memory analysis, including heap dumps and object lifetime tracking. 7. Tips and best practices ***. 1. Collect data for a representative workload *. Make sure that the workload you are using during data collection is representative of the typical workload your application will experience in production. 2. Minimize the impact of collection *. ETW tracing can have a performance impact on the application. Minimize the duration of the collection and the number of events you collect to reduce the overhead. 3. Use symbols *. Symbols are essential for analyzing performance data. Make sure that your PDB files are available and that perfview is configured to use them. 4. Start with the big picture *. Start by analyzing the CPU usage, stacks, and GC stats views to get a high-level overview of the application's performance. Then, drill down into specific areas of interest. 5. Isolate the problem *. Try to isolate the problem you are trying to solve by reproducing it in a controlled environment. 6. Use the latest version. Microsoft is continually updating perfview with new features and bug fixes. Use the latest version of perfview to ensure you have access to the best tools and features. 7. Don't assume. Always verify your assumptions with data. Perfview can help you understand the true behavior of your application. 8. Troubleshooting. One cannot find symbol errors. Make sure your symbol paths are configured correctly and that your PDB files are available. 2. Perfview crashes. Try running perfview with fewer options or collecting data for a shorter period. If the issue persists, check the perfview logs for more information. 3. No data collected. Make sure that you are running perfview as administrator and that the correct process is selected. Also, ensure that the ETW providers are enabled. 4. High CPU usage by perfview. Reduce the number of events you are collecting or the duration of the collection. Conclusion. Perfview is an indispensable tool for any .NET developer who wants to understand and optimize the performance of their applications. By understanding the various views and features, you can effectively diagnose performance bottlenecks, identify memory issues, and gain valuable insights into the runtime behavior of your code. Practice using perfview with the examples provided and experiment with different scenarios to become proficient in its use. Good luck with your performance tuning.